Here we have the problem y equals the opposite of log base 3 of x minus 2 plus 1. So this function involves quite a few transformations. So we're going to look at those transformations from the parent function first. We've got this opposite on the outside of the logarithm. So that opposite on the outside of the logarithm is a reflect over the x-axis. And then we have this minus 2 inside the logarithm, inside that argument. So that's going to take our graph right to. And then we have this addition outside the logarithm, outside that argument. So that's going to be on the outside, that's going to be up 1. So it's just our transformation rules for any of our parent functions that we're dealing with. And the parent function that we have here is y equals log base 3 of x. So when I first graph this, we're going to graph this first. And after I graph this, I'm going to then apply in order these 3 transformations. So log base 3 of x, and I think that I'm going to have to move my y-axis over here. I think that's going to be better suited right there. In fact, I'm going to move this over here. Yeah, that's going to work better. Okay, so log base 3 of x, when I put a 1 in for x, I'm going to get a 0 out. When I put a 3 in for x, I get a 1 out. And when I put a 9 in for x, 4, 5, 6, 7, 8, 9, I'm going to get a 2 out. So log base 3 of 1 is 0. So this is your x and this is your y. So you put a 1 in, you get a 0 out. Log base 3 of 3 is 1. You put a 3 in, you get a 1 out. Log base 3 of 9 is 2. You put a 9 in, you get a 2 out. So those are the 3 points that I plotted here. And we know that we have a vertical asymptote from our parent functions with our logarithms. We know that we have an asymptote at x equals 0. And our graph looks just like that. And our domain for this function is, for this parent function, we've got a domain of 0 to infinity. Those are parentheses, 0 to infinity. And we have a range of negative infinity to positive infinity. Now what we're going to do is we're going to reflect this graph over the x-axis, and then we're going to go right to up 1. So I'm going to take this point right here. I'm going to reflect it over the x-axis. Well, it's on the x-axis, so reflecting it over the x-axis does nothing. And then we're going to go right to and then up 1. So that's that new point right there. Okay? Now that point happens to be on top of an existing point, 3, 1. So I'm going to take 3, 1. I'm going to reflect it over the x-axis. And then I'm going to go right to and then up 1. And then we're going to take this last point that's on the parent function, reflect it over the x-axis. And then we're going to go right to and then up 1. And you can see that our asymptote is going to, when you reflect this asymptote, it just reflects onto itself, right? And then you go right to up 1. The up and down isn't going to impact it. It's the right to that's going to impact it. So this new graph, number 41, is going to have that green asymptote. And that's our graph right there. So I connected the 3. So this is our y equals the opposite of log base 3 of x minus 2 plus 1. And this is our parent function, y equals log base 3 of x. So the domain of our new function, it's got a domain everything greater than 2. You can also see that by setting the argument greater than 0. So the domain for this function is x is greater than 2, which in interval notation would be 2 to infinity. And the range for all logarithms is going to be all real numbers. So that's negative infinity, positive infinity. So that's where we're going to get our domain and range from. And then our asymptote, instead of x equals 0, it's x equals positive 2. And you can find that by setting the argument equal to 0 and solve for x. You can find your domain by setting your argument greater than 0 and solve for x. And that's how I got this right here. X is greater than 2. X minus 2 is greater than 0. X is greater than 2. Voila. But in interval notation, we show it like this. So there's number 41.